Hello all, welcome to Data Craft Institute. In this first video, we will understand what SQL is, why it exists, and how it is used across different data roles. At DCI, we focus on SQL from a data engineering and a data analytics perspective, the way it's actually used in real world projects. We will be using the terms SQL and SQL interchangeably throughout this video. What is SQL? SQL stands for Structured Query Language and it is the standard language used for interacting with databases. So SQL stands for Structured Query Language and it is used to interact with the databases. Now whether it is MySQL, PostgreSQL, SQL Server or modern cloud platforms like Snowflake, they all support SQL. Now SQL is used to store, retrieve and manage the data. So let us understand that SQL is the language and these databases like MySQL, PostgreSQL and SQL Server and modern data warehouse platforms like Snowflake, these are the systems that understand and execute this language. Think of it like this. English is the language and people are the speakers of that language. Similarly, here SQL is the language and databases are the speakers of SQL, but with their own different dialects. So they have a different SQL from each other. Okay. So why was SQL created? Before SQL, working with data required complex code. SQL was created so anyone could ask questions from data in a simple, readable way without writing full program. Hence, SQL was created to simplify data access, allow humans to interact with data, avoid complex programming for every query, and make data retrieval consistent and reliable. What SQL can do? SQL allows you to do everything from retrieving data, filtering it, joining tables, inserting and updating records, all the way to preparing insights for analytics. Okay, so SQL helps you to retrieve data, filter data, insert and update existing data or new data, delete data, join multiple tables, concatenate them, union them, okay, and build meaningful insights. Let us take an example. For example, this is the chart of your household expenses. You spend 52% on groceries, 4% on subscriptions, 18% on repairs, and 26% on fuels. Now, to arrive at this chart, you had data in raw format in the form of fuel bills or grocery bills or subscription bills and repair bills. You aggregated all that data, summed it up across different divisions, and then you prepared this pie chart. And now you will be taking business decisions on it, like how to improve your savings, how to increase your savings. And what would be your analysis? Maybe to reduce grocery bills. You will not increase your savings by reducing subscription bills because it is just 4%. Okay, but groceries being 52% of your expenditure, if you reduce this, you may increase your savings. So this is a data driven decision that you are taking. This is an example of a data driven decision, and this chart, a collection of such charts, is called a dashboard. Okay, so let us see how different roles use SQL to derive this. So there are basically three roles in the data worlds, three prominent roles. One is a data analyst, one is a data engineer, and the other is a data scientist. So for data analysts, SQL is the core tool to retrieve data for dashboards and reports. Most business decisions depend on SQL queries written by data analysts. Okay, so analysts use SQL to pull data for dashboard. So whatever you did here, this is an example of a dashboard. Okay, and they create reports. Okay, a collection of such charts is called a dashboard or a report. Okay, or report is more into tabular form of data. Okay, and then a data analyst will answer business questions, like a business question is how to increase the savings, what has to be reduced to increase my savings. Okay, analyze trends. This is for 1 month, this particular chart, how for every month your expenditure will look. Okay, improve decision making. Okay, based on this, take better decision, data driven decision like you took already. Okay, now SQL for data engineers. As a data engineer, SQL plays an even bigger role for transforming data, from transforming raw data to building data models and optimize heavy workloads inside your data warehouses. Okay, So engineers use SQL to build data pipelines, transform data. Transforming data means applying business logics or currency conversion. It can be anything. Okay, build data models. Now we will learn about data models in detail, but at this stage, just understand that data model is nothing but a blueprint of the data. Just like an architect prepares the blueprint of your house, so a data architect prepares the blueprint of the data, and then the data, and then we will be loading the data into warehouses, and then we will be optimizing the performance. Okay. Now SQL for data scientists. So even data scientists rely on SQL. Before any model is trained, SQL is used to extract, clean, join, and shape the data into reusable features. Okay, usable and reusable features. So in data science, there is a popular saying that garbage in and garbage out. So SQL is used to extract training data, cleaning the data, removing null values or duplicate records, feature engineering, removing unwanted attributes. For example, to predict your salary, your uh, your taste of the sports that you like is not a good feature, is not a good attribute. We will remove that. Maybe your education is, or your skills are to predict your salary. Okay, so those are feature engineering. Joining large data sets, okay, and preparing data for machine learning inputs. Okay, now SQL across OLTP and OLAP systems. There is an entire video in this module dedicated to what are OLTP and OLAP system, but at this stage, just for an introduction to SQL, I want to just highlight some how these systems use SQL. So let us understand that SQL is a language, and databases, which is on the left side, and data warehouses, which is on the right side, are the systems that understand this language. So on the left, we have applications like MySQL, PostgreSQL, SQL Server that power the day-to-day business operations. And on the right, we have data warehouses like Snowflake, BigQuery, Redshift. These are built for analytics, reporting, and decision-making purposes. So the same SQL concept works everywhere, but each platform has its own dialect and optimization. Okay, so just an initial introduction. For example, MySQL is an open source relation database. Okay, it is used in web apps like WordPress, Facebook. Okay, and PostgreSQL is a very powerful database, and it has advanced joins, JSONs. SQL Server is more like into Microsoft. It's a Microsoft relational database. It uses T-SQL, and it has strong integrations with .NET and Power BI. Okay, so these are OLTP system which support business transactions like placing an order. Okay, but storing historical data, building queries on historical data, all these things happen in OLAP systems, which are the data warehouses. So a data engineer, as a data engineer, we will be working more on OLAP systems, okay, rather than OLTP systems. So SQL in cloud platforms. Cloud platforms like Snowflake, BigQuery, Redshift, and Databricks use SQL as their primary interface for querying massive data sets. Each use their own version of SQL. Snowflake uses ANSI SQL, BigQuery has Google Standard SQL, Redshift uses Postgres like syntax, Databricks uses Spark SQL. Okay, so when we will be learning across these tools, we will be seeing how we can use them. Why SQL still matters? Even in the age of cloud computing and AI, SQL remains the foundation. It's a future proof, easy to learn, and essential for any data driven role. Okay, we all depend on SQL. It is a core skill for any data role. You check in LinkedIn for any role from director to maybe a junior analyst, they all will demand SQL. Okay, it's a universal and future proof, and it has low learning curve, but it has high impact. Okay, summary. SQL is the language for databases. It is used by analyst, engineer, and data scientist. It works across cloud platforms, and it is still one of the most important data skill. Okay, in the next video, you will understand how data is stored in databases. Thank you all.